We're all told AI is the future, right? But what if its very design is pushing us towards an energy crisis we can't afford? Today, we're going to dig into the massive billion-dollar bottleneck that's holding AI back and the truly incredible fix that engineers found by, well, looking right inside our own heads.
Okay, so behind all the magic of modern AI, there is a huge problem bubbling up just beneath the surface. And it's not a software bug, it's a hardware problem. And frankly, it's becoming completely unsustainable.
Just try to wrap your head around this number. 176 terawatt hours. That is the insane amount of energy that data centers around the world burned through in 2023. And with AI's appetite growing, that number could easily double by 2028. We're not just talking about high electric bills anymore. We are talking about hitting a very real physical wall.
So what gives? It's not just about crunching huge amounts of data. Why are these systems, which are supposed to be the height of modern efficiency, so unbelievably thirsty for power?
Well, it all comes down to AI's unsustainable energy habit. And what's really wild is that the biggest cost isn't even the massive calculations themselves. It's all the time and energy wasted just shuffling data around.
Here's the core architectural flaw in a nutshell. Our modern processors are unbelievably fast, but when it comes to AI tasks, they spend most of their time just sitting there, waiting. It creates this massive data traffic jam. And get this, only about 10% of the energy is actually spent on doing the math. The other 90%? Yeah, that's just wasted moving data from one place to another.
And this fundamental problem has a name: the von Neumann bottleneck. It's all based on a computer design that is, believe it or not, over 75 years old. It was a brilliant idea for its time, but it was just never, ever designed for the kind of work AI needs to do.
So this idea first pops up way back in 1945, and it quickly becomes the blueprint for basically every computer on the planet. For decades, it worked perfectly. But today, that exact same design is the very thing causing this crippling traffic jam for AI.
The heart of the problem is this physical separation. In a von Neumann computer, the part that does the thinking, the processor, is in a totally different place from the part that holds the information, the memory. And they're connected by this little data highway that's just way too narrow for today's traffic.
This quote just perfectly nails the issue. See, general computing is like that deli. It's flexible, it's ready for any random order that comes in. But AI is completely different. It's not about variety, it's about mind-numbing, repetitive volume. It's that order for 5,000 tuna sandwiches all at once.
Think about it. A regular computer processor is a jack of all trades. It's great for running your browser, a spreadsheet, a video game, all at the same time. But AI workloads? They're incredibly simple and predictable. It's basically the same simple math problem over and over and over again, billions of times. For that kind of work, the von Neumann design is just horribly inefficient.
So, if our 75-year-old blueprint is broken, where on earth do we look for a new one? Well, it turns out the answer has been with us the entire time. We're finally learning from the most powerful, most efficient computer ever known, the human brain.
And this is the big what-if question that's driving a whole new field of research. What if we stopped trying to build faster calculators and instead tried to build something that fundamentally works more like our own neural networks?
The brain is just a masterpiece of design. It does incredible parallel processing, with billions of neurons all working at once. But here's the real secret sauce. In the brain, memory and computation are not separate, they're fused together. And that's why it can handle incredibly complex thoughts using just a tiny bit of energy.
And that inspiration has led us to this revolutionary new idea, computing inside of memory. It's a complete paradigm shift, a total rethinking of how a computer chip should work, all designed to finally break that von Neumann bottleneck.
The concept is actually pretty simple, but it's profound. Instead of pulling data out of memory, sending it to a processor, doing the math, and sending the answer back, why not just do the calculation right where the data already lives? That's in-memory computing, and it completely eliminates the data traffic jam.
And this really shows you the difference, doesn't it? On one side, you've got that classic traffic jam. On the other, you have this thing called a resistive crossbar array. Now, don't get bogged down in the name. The key idea is that the data is stored in the grid itself. The calculations happen all at once, in parallel, just by sending electricity through it. The data never has to go anywhere.
Okay, so there is one little catch with this new analog approach: precision. It's not always perfect.
But of course, engineers came up with a really clever hybrid solution. This is IBM's mixed precision architecture, and it really gives you the best of both worlds, the raw, incredible speed of analog with the pinpoint accuracy of a digital computer.
So here's how this clever trick works. The fast analog chip does all the heavy lifting, right? The vast majority of the calculations. At the same time, a normal digital unit is just keeping track of the small corrections needed. It lets those tiny updates add up until they're big enough to matter, and only then does it update the analog chip. It's genius, really.
So, what does all this clever engineering actually get you? How about a 25-fold improvement? Hardware like IBM's North Pole chip, using these very ideas, delivers up to 25 times the energy efficiency of the best GPUs we use for AI today. Let that sink in for a second. 25 times. That's not just an improvement. That is a complete game changer.
And make no mistake, this isn't some far-off sci-fi concept. We are standing on the edge of a full-blown neuromorphic revolution. This technology is creating an entirely new, multi-billion-dollar market from scratch.
I mean, just look at the money pouring in. The market for these neuromorphic chips is projected to absolutely skyrocket, from about $1/3 billion in 2025 to almost $12 billion by 2030. That's a growth rate of over 104% per year. It's just explosive.
And this tech is going to pop up everywhere. The car industry is already jumping on board for smarter driver assistance systems. But the fastest growing area is healthcare. We're talking brain-computer interfaces, smarter medical devices, you name it. And of course, it's going to power the next wave of robots, phones, and so much more. Okay, but let's not get ahead of ourselves. It's not all smooth sailing just yet. There are still some pretty big hurdles. We need to build a whole new world of software for these chips. Making them perfectly, consistently, at a massive scale is really hard. And the whole industry needs to agree on how to test and validate them. The potential is massive, but the road ahead is still pretty challenging. Which leaves us with this one kind of mind-bending final thought. For 75 years, our computers have basically worked like really, really fast calculators. We are now on the verge of building computers that work more like brains. So the question isn't if this is going to change our world, but how profoundly. What happens when our technology really starts to think?